So basically, there are two types of mechanical energy, right, in general, which is potential energy and kinetic energy. This potential energy here, we can categorize into two types as well. One, you call it as gravitational potential energy, which is mgh. Another one is called it as elastic potential energy, which is given as half k delta x squared, right? So elastic potential energy is actually the energy stored in spring. Energy and work are actually related to one another, or close related to one another, okay? Because both of these terms, whether it is work or energy, both of them has the unit of joule, okay? So how to get the elastic potential energy of half kx squared? Then you may refer to what is the work done by the spring. Okay, for example, if I have a spring, this is a spring, and attached to a mass, right? And the spring constant of the spring is k, spring constant of a spring, okay, which is measuring the elasticity of the spring. So if K is higher, means it is stiffer, and means it is very difficult to stretch or compress. For example, initially the spring is at relax, at equilibrium of x equal to 0. So when you stretch the spring, so that the spring is stretched to the displacement of x, so this is a extension of the spring that you stretch it, or you can also compress it. Either you stretch it or compress the spring, okay, with the displacement of x, for example. And I like to know that if you stretch it to the displacement of x, or you compress it to the displacement of negative x from the equilibrium is x equal to 0 here, okay? So we can find out what is the energy stored in the spring. So energy and work is actually closely related to one another. Work done by the spring is equal to F dx. Okay, this force will be the force exerted on the spring. So I want to get the total work. I integrate from 0 to x, right? So when I integrate, this is the F, this is the x. So integrate F with respect to x, you will get Fx, all right? Or before, according to Hooke's law, force exerted on the spring is equal to negative kx. But now we are interested to get the magnitude only, so we ignore the negative, right? Negative just to show that the direction of the force or the restoring force stored in the spring is opposed the direction of the displacement. So that's why you have a negative there. So this F here, we call it as restoring force. If I substitute the F with kx dx and integrate from 0 to x, because, all right, with the displacement of x, okay, for example, then I will get it as kx squared divided by 2, or the energy stored in the spring is given as half kx squared. That's how you get the half kx squared here, okay? So the other form of mechanical energy is kinetic energy. So this kinetic energy here, there are two types. One, you call it as translational kinetic energy of half mv squared. Another one is called it as rotational kinetic energy of half I omega squared. I is called it as moment of inertia. Different shape of an object has a different formula for a moment of inertia, and it also depends on the axis of rotation. So we will focus on this topic later. Omega is called it as angular speed. Work is defined as the product of force and the displacement, and work is actually a scalar quantity, right? So since it is a dot product, so I can also write it as F delta S cos theta, and it has a SI unit of joule. This is work. And now I'm going to introduce to you one theorem. Okay, we call it as work energy theorem. Work energy theorem, or sometimes we call it as work kinetic energy theorem. So according to this theorem, the net work done is equal to the change of kinetic energy, which means this work done is used to change the speed of the object. Kinetic energy final minus kinetic energy initial is the net work done. Half mv final squared. So minus half mv initial squared, right? Or half mv squared minus half mu squared also can. Here is a theorem of the net work done, where the net work done is always equal to the change of kinetic energy only, right? Change of kinetic energy only. And also, you have to know another one is the work done by the gravity. Okay, so it's always equal to the negative change of potential energy. work done by the gravity is equal to the negative change of potential energy. Change means we are using potential energy final minus the potential energy initial. Okay, remember to add the negative in front. It means mgh final minus the mgh initial. That is the potential energy final and potential energy initial. So why we must add the negative here? Okay, just imagine that if I have 2 points, point A, which is higher, point B, which is lower, potential energy at point A, I call it as PEA, potential energy at point B, I call it as PEB. Okay, and gravitational force is always directed downward, so this is a gravitational force. If let's say this is the initial point, and this is the final point. Okay, so the work done by the gravity is then equal to potential energy final minus the potential energy initial. And from the diagram, I know that potential energy at point B is lower than potential energy at point A, right? Or PEB is less than PEA. So when I minus, I will get a negative value, okay? If I don't include a negative in. But then work is defined as a force dot with the displacement. You will get a positive work if force and displacement are in the same direction. W will be negative if F and displacement are in the opposite direction. Right? So now, the force is pointed downward. Okay, the displacement also going downward. If I don't add a negative, I will get a negative value work done by the gravity, which is not consistent with our discussion here. So that's why I add a negative there. So that's eventually the work done by the gravity is positive, and it is consistent with what we have learned earlier. So basically forces, there are two types of forces. One is a conservative force. Another one we call it as non-conservative force. So example of conservative force would be like gravity force or gravitational force, the spring force, electromagnetic force, tension force is also part under conservative force. However, non-conservative force will be, the example would be like kinetic friction or frictional force in general, kinetic friction, air drag, propulsion force. We have a principle, call it as a principle of conservation of mechanical energy. E initial is always equal to E final, means energy is conserved. So usually we apply this when there is no frictional force exists, or when there is no non-conservative force exists in the example, or in a problem that we are going to solve it. So we apply this. E initial is always same as E final. So what is E? E means the total mechanical energy. So mechanical energy consists of kinetic energy and the potential energy. So of course, kinetic energy, there are two types as well. One is translational kinetic energy, and another one is the rotational kinetic energy. So this is the initial. Potential energy, there are two types also, gravitational potential energy and elastic potential energy. Okay, final, so we have translational kinetic energy plus rotational kinetic energy final, plus potential energy, gravitational potential energy plus the elastic potential energy final. So this is a complete expression for conservation of mechanical energy. And remember, E final is always same as E initial. In the other words, if E final is equal to E initial, means the change of energy is equal to 0, right? Okay, change means what? So change means final minus initial is equal to 0. So that's why E final is same as E initial. Okay, right? So we just introduced to you there are two types of forces, conservative force and non-conservative force. So we have to include what happened if the non-conservative force exists. So what is non-conservative force? Frictional force, propulsion force, air drag. So in this case here, if non-conservative force exists, or present, then the change of energy is not equal to 0 anymore, but is equal to the work done by the non-conservative force. Right? You can see the difference. Okay, the change of energy is equal to the work done by the non-conservative force. Or I can write it as work done by the non-conservative force is equal to the change of energy. So what is change of energy? Energy consists of kinetic energy and the change of potential energy. So you have to remember this. If non-conservative force present, work done by the non-conservative force is equal to the change of kinetic energy plus the change of potential energy.